Welcome students for part 4 revision class of chapter 2. So we supposed to do sum number 14 now. Sum number 14 is 4-point charges q, small q, capital Q and small q are placed at corners of a square of side A as shown in the figure. So this is the diagram. Okay, so I want to find the resultant electric field on the charge capital Q and potential energy of this system. So let us first find the resultant electric field on charge capital Q. Any one of the charge you can choose and you can find the resultant electric field. Okay, this is electric field, electric force, sorry, resultant electric force. Okay, so this is the diagram. So this is the diagram. I want to find electric force at this point. So let us first see the electric force due to this charge, this Q at this point will be, electric force will be, it is a repulsive force. This will repel this. So the force will be along this direction and force due to this charge will be along this direction. So force due to this is, let me call it as Fc, and this is called as Fa. So this is the force due to the charge at A. This is the force due to charge at C. The resultant of these two force will be along this direction. This is the resultant force. So let us first calculate Fa. So which is equal to K Q Q. Okay. So between these two charges, K Q Q by R square. So distance is A, therefore it is A square. Similarly, Fc is, it is also same. So it is KQQ by A square. Okay. So now I want to find the resultant of these two fields. So what is the formula for resultant force? I have to use our parallelogram law of vectors. So F is equal to whole root of, what is the formula? F1 square, that is Fa square plus Fc square plus 2Fa Fc cos theta, and theta is 90 degree because angle between this Fa and Fc is 90 degree. Therefore, this is 90 degree. Cos 90 is 0. Therefore, you will be having only these two. F is equal to whole root of Fa square plus Fc square. Okay. And then now we substitute the values. So F is equal to whole root of, what is Fa? Fa and Fc are equal. So this is Fa square. Let us call this also as Fa square. So it will become whole root of 2 times Fa square. Root 2 times Fa is the resultant of these two forces. So which is F is equal to root 2 times, what is Fa? Fa is the first equation, K Q Q by A square. This is F. This is the resultant force of those two forces. Okay. And now I want to find force on this charge due to this Q charge. Due to this Q charge. Okay, this Q charge due to this charge. So this is the distance between these two charges that can be obtained by Pythagoras theorem. If you want x, the x square is equal to A square plus A square. X square is equal to 2A square and x is equal to root 2 times A. This is x. The force between this capital Q and this capital Q will be F of capital Q, and it is this Q at B exert force on this Q in this direction only, repulsive force. So this is the force due to F capital Q charge. So the total force will be sum of this Fq and F. So by total force will be FQ plus F. What is FQ? FQ is the force between two capital Qs. So K, Q1, Q2, both of them are capital Q by R square. So R is X. X is already known, it is 2 root 2A. So X square means root 2A the whole square. So KQ square by 2A square. Okay. So now let us find the total force. Total force Ft is equal to Fq, that is KQ square by 2A plus root 2 KQ Q by A square. This is 2A square. So now I can take common out this KQ by A square. So remaining will be Q by 2 plus root 2 Q. Okay. So this is the resultant force of all the three charges at charge capital Q. So let us now do 14B. So what is that 14B? I want to find the potential energy of this system. So the potential energy of this system at this system is general formula for potential energy is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. This is the general formula. So first QAB is nothing but 1 by 4 pi epsilon naught capital Q small q by A. So U BC is similarly 1 by 4 pi epsilon naught capital Q small q by A. UCD is 1 by 4 pi epsilon naught. This electrostatic potential due to charges at C and D. So will be again QQ by A, and similarly U of dA is also same QQ by A. But we have these two pairs of charges, that is B and D, A and C. So what is that? U of PD. BD means charge at B and charge at D. So formula is 1 by 4 pi epsilon naught Q1, Q2. So both of them are Q, therefore Q square by distance is X. X is already known, it is 2 root 2A. Similarly, on this side, A and C, here also the distance is same, X only. Therefore, U of AC is also epsilon naught Q square by 2 root 2A. So what is the total potential energy? Sum of all these values. Therefore, I can take 1 by 4 pi epsilon common because it is all there in all the terms. And then I have QQ by A 4 times. So I'm just writing it as 4 times QQ by A plus this is Q square by root 2A plus Q square by root 2A. Okay, so U is equal to, I can take now capital Q out. So Q can be taken out by 4 pi epsilon naught. A also can be taken out. Remaining will be here. So I cannot take this Q, I can take this Q. So this 4Q plus Q by root 2 plus Q by root 2 again. So 2 times Q by root 2. So I can write it as 2 times Q by root 2. So U is equal to Q by U is equal to, sorry, So our u is equal to sum of these. So this is the formula for